surface integral 1 and 2 questions you can write a test. Okay, this is the question number 1, problem number 1. You can write test. This is very important only. And this is 2. Now volume integrals, because I thought you will be joining but you are not joining. I told for afternoon class only I will be going. After teaching my first morning class, I thought after 12 o'clock I will be not available. So I thought 9 to 11 your class is there, but you not attended. So I started like recording. Okay, volume integrals, any integral which is evaluated over a. Now I sent 3 videos, please watch that, then you will understand very easily. The pictures bring to your mind. Okay, for that purpose only I have sent that video. To enrich the knowledge of line, surface and volume integrals. Okay, that will not come for exam, but that will be useful to you, otherwise it will be difficult to you. That's okay. Now any integral which is evaluated over a volume, the picture you can bring to your mind is called a volume integral. If V is a volume bounded by a surface, so just now be shown a surface. The volume is interior like a golden color in the picture you can see. Okay, and the surface is the S, then covered by the surface. So integral, triple integral volume F vector into D vector, that is differentiation with respect to volume, is called the volume integral of F vector. Now problems. If F vector is equal to 2xz minus xj x y square k vector, evaluate F vector. Evaluate integral over V F vector dV, where V is the volume of the region bounded by the surfaces x equal to 0, x equal to 1, y equal to, that is 0 to 1, 0 to 6, and z is x square to 4. So the given vector can be written as, that is F vector can be written as triple integral, right? Triple integral x equal to 0 to 1, y equal to 0 to 6, and z is equal to x square to 4. So first we have to write F1 vector, F2 vector and F3 vector with dx, dy, dz. Clear? Clear here. Now we have to enter all dx, dy, dz separately for each F1 component, F2 component and F3 component. Now keeping I as constant outside, and 2xz, here we have 2xz. Okay, 2xz as a F1 component, F vector component, F1 vector component, 2xz dx, dy, dz. And F2 is only x, that is here negative symbol is there, k can commonly outside, x dx, dy, dz, and plus next k vector, that is k component, and this integral dy, dx, dz. Okay, this is the equation number 1. Now let us consider that x axis, like the I component. Okay, the first I component, 2xz dx, dy, dz. Almost we do with the first dz integration. Okay, integrating with the dz, then integrating with the dy, then integrating with the dx. Okay, now integrating with the dz, here 2xz is there, z is there. Now integrating, we have 2x, here z is there, differentiating with respect to z, integrating with respect to z, what happens, z square by 2, in the denominator you will get 2. So what happens, z square by 2 and 2 get cancelled, x will be there. Okay, now we have like integral over 0 to 1, 0 to x z square, and the limits are x square minus x square, lower limit is x square and the upper limit is 4. Okay, dx, dy. Now you have to do integration with dy. Now integrating with the dy. Okay, integrating with the dy, what we have, dy, if you integrate, x 16 minus x to the power of 4 dy dx. After integrating, here x is there and integrating with the dy, right? Y to the power here y will be there, x into 16 minus x to the power of 4 into y dx. Okay, next here now here 0 to 1 the limits x into 16 minus x to the power of 4 y 0 to 6 is the limit. Now you apply the limits as 6. Okay, the lower limit will become 0, so only apply the upper limit. What will get? 6x 16 minus x to the power of 4 dx. So now what we have to do is take 6 commonly outside and you multiply this term. Please do, this is very important, each and every calculation do slowly step by step. 16 into x is 16x and this become as a x to the power of 5 and dx. I think you got it. And now you are integrating, right? You are integrated. Now 16x x to the power of 5 integrating, what happened with the x square by 2, that is 16 x square by 2, 2 1s are 2, 2 8s are 16, get cancelled, only 8x square will be there. Okay, now for this x to the power of 5 by x to the power of integrating x to the power of 5 is x to the power of 6 by 6. Okay, now applying 1 as a upper limit, here 1, so the 1 only, right? 1 square is 1 only, so 8 and minus here applying x as 1, x is equal to 1, we have 1 over 6. Now do cross multiplication, like 8 6 are 48, 48 minus 1 by 6 is equal to 40. Here it is a 6 is outside, the 6 is outside, right? 6 get cancelled, 48 minus 1 is equal to 47 is the answer. Now we have to integrate with dy, that is this term. Already we finished about dz. Now we have to integrate with dy. So x dx dy dz can be, it becomes now 0 to 1, 0 to 6 x z dy dx. Okay, so now integrating with dy. So here the z dz will become x and the dz integration of dz becomes as a z. Okay, and dy dx. Here the limits are, for z limits are x square to 4, z limits are x square to 4. Okay, now integrating dy dx. Now integrating dy dx, x of 4 minus x square dy dx. What happened? For y will be there. If you integrate dy dx, y will be there. Now applying the y, after integrating with the dy, we have to substitute the value 0 and 6. So the lower term will become 0. Now only we have to substitute the upper term, that is with the 6. Okay, what happens? It is like a 6 minus 0. Okay, take this 6 as a constant over here. Take the 6 constant as over here, and this is automatically 4x minus x cube. Again now integrate with the dx. Okay, now integrating with the dx, what we have? The x will become x square by 2, right? And here 4 will be there, that it will be get cancelled. Like a 4x square by 2, this will be get cancelled and 2x square will be there, that is here, and it is x to the power of 4 by 4. Okay, next what happened? Upper limit as 1. So after substituting here as a 1, 2 1s are 2, and here it is like a 1 by 4. Here up to it is clear. Now take LCM or cross multiply. 4 2s are 8. 8 minus 1 by 4. Here it is a 6. Okay, 8 minus 1 by 4 is 7. 6. 7 by 4. Okay, now 6 7s are 42 by 4. What happens? 42 by 4. 42 by 4. Now you can go with the simplification with the 2 table. 21 by 2, that is 2 2s are 4, 2 21s are 21. So 21 by 2 is the answer here. Okay, now consider x, y, z, right? We have three components, f1, f2, f3 component. Okay, now we are taking for f1 component we got 47 for f1 component. Okay, and f2 component we got 21 by 2. Next f3 component we have to deal with. Okay, by the question we have f1 as this term. Okay, this is f1, and this term as f2, and this term as f3. So what we have done, separately we are integrating. Okay, this is f2 and this is f3. Okay, now y square k, we have to integrate y square k with all dx, dy, dz. Okay, finally now we have the third term, that is f3 term. Integral over 0 to 1, 0 to 6, x square to 4. So y square dx, dy, dz. First we will integrate with the dz. Okay. So what happens? Y square z will happen. You have to arrange in a order way. First you can write one more step also here by arranging y square dz, dy, dx like that. Okay. Then after we can integrate here. Here y square, after integrating z will be there, and the limits are x square and 4. Okay, and now in the next line 0 to 1, and again we are integrating with the dy. After integrating with the dy, we got as a y square will become y cube by 3. Okay, and the limits are 0 to 6. This here z is nothing but we have z value. Z is equal to 4 minus x square. 4 minus x square. Okay, the z value is 4 minus x square. We are entering the value 4 minus z square, x square. Okay, here we have z square. So z is like 4 square minus x square. So z is equal to upper limit and lower limit. So it is nothing but 16 minus extra power of 4. Upper limit, and this is lower limit. Lower limit. Okay. Now considering f3 component, that is f vector, that is k component, y square dx, dy, dz, we have z, y square, z dz, dx, dy. So z was integrated. Now we have to apply the limits 4 minus x square. Now we have to integrate the y value also. So y cube by 3. Step by step we have to do. Okay, y cube by 3. Now you have to enter the upper limit because the lower limit is 0. Now enter the upper limit. As y is equal to 6, for upper limit is 6. So 6 cube by 3. And here the limits for this only 0 to 1, taking commonly outside because this is a constant, 4 minus x square into dx, and this can be 6 times 6, 6 6 are 36, 36 into 3. And 6 cube is nothing but 108. 6 6 are 36, 36, sorry, 6 cube is nothing but 216 over 3. Now what happens? 3 7s are 21 and 2 3 2s are 6. So 72 will be there. Here 72 will come. Okay. 6 cube is nothing but 216. So 72, and again you have to integrate with x, 4x, x cube by 3. Again applying the upper limit, 4 ones are 4, 1 by 3. So now we have to do cross multiply. 4 3s are 12. 12 minus 1 by 3, which is equal to 11 by 3. 11 by 3. So 72 times of 11 by 3. Now you can here simplify. 3 ones are 3. 3 2s are 6 and 3 4s are 12. Okay. 3 2s are 6. 1 is there. 3 4s are 12. Now 11 into 24. 24 ones are 24. Again 24 ones are 24. So it is 264. Now we have to find the volume. This is volume of integral. Volume of integral formula is f vector dv is equal to x axis, f1 is with the I component, f2 is as a j component, and with the f3 is k component. We have to enter the values. Already we have f7 and 21 by 2 and 264 we found. We have to enter the value in the equation 1. That's it. This is called a volume of integral by the given area, given equation, given volume. Now second problem, if f vector is equal to, second problem, if f vector is equal to 2x minus 3zi, 2xyz minus 4xk component, evaluate triple integral v. That is in the question itself they asked curl f vector dv vector. That means volume of the volume of the vector, but you have to find in a curl way. Curl is nothing but we have to go into the cross product. We have to use in a cross product. That is a determinant method we have to use here. Okay, where is the volume enclosed by the region? Almost if you whenever you get curl, you have to use cross product method. Okay, bounded by the planes x equal to 0, y equal to 0, z is equal to 0, and 2x plus 2y plus z is equal to 0. So it all the x, y, z, all the planes are pausing from the 0, enclosed curve. You can imagine the, when please you can go with the cylinder. Already I shared one video. You can find out how to imagine. Okay. Now the equation is 2x plus 2y, 2x plus 2y plus 2z. The equation plus z is equal to 4. Plus z is equal to 4. It is the equation. Okay. Now here the component in curl f vector component we have f1, f2, f3 and partial derivatives as now this one keep it as a constant. Now we have to differentiate dou y with minus 4x and again with this one. Okay, first this term, then this term, minus of this term. Okay, already I sent the two or three examples about partial derivatives. After watching this, it will be easy to you. Here, is there any y terms? So there is no y terms, so it is a 0. And here it is any z term, so there is no z term. Dou by dou y is equal to minus 4x. So you can't integrate dou by 4x. Okay. Here dou by of negative 4x is 0 because there is no y term, so it is a 0. So it is a constant term. According to that, it is a 0. Okay. Now dou by of minus 2xy. Here there is no z term, so it will become 0. So dou by dou z is equal to 0. Now taking j component, so it should be a negative symbol. While taking j component, it should be a negative. Okay, negative symbol. Now you forget about this line. Okay, now we have to deal with this line and this line. So dou by dou x of minus 4x, dou by dou x of minus 4x is minus 4. So that is the term. Next, 2x square minus 3z with dou z. 2x square minus 3z. Here we have to derive with dou by dou z. Dou by dou z. Now this term will become 0 and only minus 3 will be the answer. So here we got minus of minus 3z. Here we got for lower limit almost it is a minus. So minus of minus it become plus 3. Lower limit we enter like a negative symbol only, negative symbol. Okay. Now k component, for k we have to forget all those things. Now we deal with this one and this one. Okay, minus of 2x. So differentiating minus 2xy is what? Minus 2y. And with it 2x square dou by dou y. Now dou by of 2x square minus 3z. We have to differentiate with dou by dou by. There is no terms, so you will get 0. This term will become 0. Okay. Finally, we have that I axis, that is f1 vector is totally 0, and we have f2 vector and f3 vector, and 4 minus 1 is nothing but minus 1. Here it is a minus 1. Already outside we have minus, so minus of minus will become plus, and here minus 2y. From the equation we have 2x plus 2y plus z is equal to 4. From the equation we have, we can have the value of z is equal to 4 minus 2y minus 2x. Okay, 4 minus 2y minus 2x. So that is only 4 minus 2x minus 2y. That again we have to replace it as y equal to 0 in the equation. Here put z is equal to 0, we got this equation. And if we put y is equal to 0, we will get this term as a 0. So we have 4 minus 2x. Take 2 commonly outside, 2 minus x will be there, and this is equal to 0, and this also, this 2 will become 0, so only 2 minus x will be there. So only y equal to 2 minus x. Now again you have to put y equal to 0. Okay, now if you have x is equal to 2, whichever left, if x is equal to 2, that is the equation here, leftover equation. Put y equal to 0. If y equal to 0, x is equal to 2 is the answer. Okay, y is equal to 0 and x is equal to x minus 2 will be there, and x equal to 0. Next we have, now we have to apply triple integral del cross f vector. This is the curvature formula, curvature or curl formula, curl or circulation, we can call it as a circulation also. Circulation, yesterday I played a video about for this circulation. I showed the images also for circulation, how the electric field, magnetic field will be produced when a particle moves around its triple integral del cross f vector into dv. So taking the limits for the derived values, that is j minus 2y k components, j vector minus 2y k vector dx dy dz. First take dz differentiating, integrating, then with integrating, then x integration. Okay, here it is the formula for volume integration, volume of integration formula, triple integral del cross f dv. Derivative with volume, deriving with volume, integrating with volume. It means integrating with volume, integration of with volume. Next, the applying the limits, and we are integrated with dz, we got z. Okay, now applying this z value in this, we have 4 minus 2x minus 2y, and this term as it is. Okay, now we have to integrate with dy. Now integrate with dy, what will happen? 0 to 2, 0 to 2 minus x. This term we can j component, and we have to multiply over here because these are all in the bracket. Bracket, it is a product. There is no, we want to give as a cross or dot. It means if it is a product, suppose 6 2 into 2 is 6 2 is 12, like that. Here also multiplication. Now we are multiplying with the j term. Again we have to multiply with all these together with this term. First j term. Now minus 2yk, minus 2yk, this entire minus 2yk and this whole term. Okay, here you have written, and dy by dx. Now integrating with the dy, each term integrating with the dy, we have, wherever we find y, we need to integrate. Here there is a constant term, Now integrating it will come 4y, and here it will is a 2xy, and here it is a y square by 2. This 2 will get cancelled. Okay, the 2 and denominator 2 will come, that will get cancelled, y square. And the limits are 0 to 2 minus x. Here it is there, 0 to 2 minus, and here minus 2 k vector, minus 2k vector, take it commonly outside because that is constant terms. And here you have to simplify. Here it is y square by 2. You will get 4y, isn't it? 4 into y you will get. Okay. Now here we have to integrate. Here this term will become 4y, and this will become 2xy, and this will become 2y cube. Okay. Here first of all we have to keep only 2k, minus 2k, keep it here. Okay. Send this y inside first of all. It becomes 4y minus 2xy minus 2y square. Then we have to integrate. Now we have to integrate. Okay. Now if you are integrating with dy, what will come? 4y square by 2. 4y square by 2 first term. Then the 2 will get cancelled. So 2y square you will get. Here minus 2. Here y square by 2. This 2, that 2 is get cancelled. Xy square. Here also y cube by 3 will be there. So automatically minus 2y cube by 3. Okay, now integral over 0 to y equal to 0 to 2 minus x. After minus 2k, the equation, after that we have to apply the limits 2 minus x. Wherever you find y, you have to apply 2 minus x. Here y is equal to 2 minus x. We have to enter y is equal to 2 minus x. Here y, here 2 minus x. Here 2xy. Here also we have 2xy. And here 2 minus 2x, the y value. Here y square value. Okay. And again we have to enter here also y as 2 minus x in these values. We have to substitute. Now for k components, minus 2 by 3 taken commonly outside. Yet minus 2 by 3 in the denominator taken commonly outside. 2 by 3 taken commonly outside, and the k value also outside. That is k component. Okay. So 6 into 2 minus x whole square. Here 3 is the denominator. We have to do LCM or cross multiply to these two terms. It becomes now 3y square minus 3x square y, 3x square y minus 2y cube. Okay. Then integration of dx. We have the limits y equal to 0, y equal to 2 minus x. First we have to substitute the value with y as a x, 2 minus x. Wherever you find y, you have to substitute as a value 2 minus x. Now you can take 3 as commonly outside, 2 over 3k component as outside. Now 2 3s are 6. Okay. 2 3s are 6, and y, substitute the y value 2 minus x whole square. Now again 3 1s are 3 here into x. Y term is a x square, y term is a whole square, and this is a y term. And minus 2, this is a y cube term into dx. Now integral over dx. I think you got it. Next x is equal to 0 to 2 into dx. This is a j term, and this is a k term. This is a j term. 2 minus x. Up to here it is there. Up to here it is there. Up to here you can go through here. From this here I will be dictating by giving the notes. Okay. Up to here I am stopping. Okay. From here I will be giving the note.